Hello, welcome to Math 1324. This is Chapter 5, Section 3, Example 9, I believe, which is, of course, the last example in this chapter. Okay, so in this example, we have a woman buys a house for the average cost of a house in Amarillo for $142,873. She plans to pay it off in 30 years, the industry standard. What should her monthly payments be if she receives a 4.2% interest rate compounded monthly? How much interest does she pay? Okay, on A, we can just use the easy calculator. So if we go to easy calculator, we go to 142,873 for the loan amount, the interest rate of 4.2% for 30 years. If we calculate that, the monthly payment is going to be $698.67. Helps if I write it in the correct place. As for the total amount of interest that was paid, that was $108,648.20. Okay, so let's talk about that. $142,000 for the house, $108,000 for the just total amount of interest. So the total amount that was paid for the house is around $250,000. So it's getting pretty close to that. And the only reason why it's not actually the cost of the house is because the interest rate wasn't all that high. If you go to even a 6% interest, it's $165,000, which is more than the cost of the house. And I think it's right around 5.3, 5.4%, where the total amount of interest is going to actually be the actual cost of the house. You would actually be doubling the amount that you're paying for the house. So that's why interest is so important to us. Okay, good. Letter B. Because she's about to know what I'm about to tell you, or she knows what I'm about to tell you, she then decides to just purchase a house for 15 years instead of the standard 30 years. However, she can't afford to pay any more a month. How expensive of a house can she afford? How much interest will she have paid over the 15 years? Okay, so this one, we don't know the value of the house. That's what we need to figure out. So we need to use the TVM solver. Now the total number of payments, monthly payments for 15 years is 180 payments. We're going to assume the same interest rate, and the present value is what we want to know. The payments are going to stay the same from right here, and we're going to type them as a negative. Future value will be 0 because we'd like to amortize the house, and 12 payments per year. And instead of showing you or just telling you what you would get, let me go ahead and show you the easy calculator again. If I go back to the home screen, and the very first thing, top left, is TVM calculator. It looks a little bit different from what the other one is. And notice that the mode end or begin is here, but you can go to different decimal places here as well. Okay, so the present value we don't know, but the payments are going to stay the same that we had last time, which was negative 698.67. So same payments. Future value should be 0, interest rate of 4.2%, and the total number of periods is 180. And then to calculate the present value, just click on present value. Notice it says $93,187.02. And there you go. That's the size of the house that she can get. And to figure out the interest, well, you can go through this, multiply the payments by the total number of payments, and then subtract off from the present value. But let me go back to the calculator here. So that was weird. 93,187.02. Is that right? Yes. Oops, come on. The interest rate, still 4.2% for 15 years. Notice 698.67, good. And notice that the total interest is 32,573.58. Is that correct? Yes. Good deal. So that's the amount that she earned in interest. Or she paid in interest, sorry. Good deal. Next, letter C. At the end of this 15 years, she now has extra room in her budget because that house is now paid off. And so she decides to put the monthly payments in an IRA that yields 5% yearly interest, compounded monthly. How much will she have in the IRA after those 15 years? And how much of that is interest? Okay, so for letter C, this is a TVM solver situation again. Again, we still have 180 payments. The interest rate this time is 5%. The present value is nothing because you start with nothing in the account. The payments will remain the same from what we saw before. The future value we don't know, that's what we want to figure out. P/Y, C/Y will still be 12. Now let me go ahead and go to the TVM solver again in this. So the present value is 0. The payments are negative 698.67. Future value we don't know. The annual interest rate is 5%, and the number of periods is 180, 12 times 15. And then to figure out the future value, just click on FV. 186,746.77. Good. And that's how much would be in the account after those extra 15 years. And you can figure out the interest here by doing 180 times the 698.67, and then then subtracting off the 186,746.77. I'm not going to do that. You can do that on your own. What I care about here is look at what's happened. By buying a 30-year mortgage or getting a 30-year mortgage, yes, she gets a decent house, but she pays almost double for it. But by buying a slightly less, probably impressive house, and probably a smaller house as well, she pays it off in 15 years for the same amount, but it's not worth half the amount. It's just, probably about a third of the amount, or 2/3 of the amount. But then she has money left in her budget, and she takes that money and starts putting that into an interest-bearing account. And it's only 5% interest. And at that 5% interest, she actually earns, or she then has $186,746.77 in there. And what's important to understand is that she not only has a house that was worth $93,887.02. She also then has $186,746.77, which is actually even more than what the original house was worth. So at the end of the 30 years, she not only has a house, but she has more money than she would have for the cost of that house for the 30 years. And now this might be a little bit extreme, right? The $93,000 as opposed to $142,000. There's a lot of difference in those types of houses. But what's important for you to understand is that while, yes, the industry standard is 30 years, I beg of you, don't do 30 years. Do 20 at most if you can. Preferably 15. 10 is starting to push it, but 15 is probably better. 20 if you need to. But at the end of that time, take your money and invest it. And you will then have more money in the account plus the house than you would have had otherwise. So while, yes, houses are important equity builders, you can build equity by just putting money in the bank. Okay, so just remember that. All right. Well, I believe that's it. I'll see you in the next chapter. Have fun.